Okay, so today we're going to do transformations of logs. You'll recognize the same format above. We're going to pick apart the format and say what the letters mean. So when that letter A, when A is greater than 1, what does it do? Vertical stretch. When A is between 0 and 1, it's a vertical compress. And when A is less than 1, or it's negative, it's a reflection. Over what axis?
Wait, what is the second one?
It's a reflection over which axis? X-axis. Okay. The B value is, that's a horizontal movement. When B is greater than 1, it's a horizontal compression. When B is between 0 and 1, it's a horizontal stretch. And what you do is you flip B around. And when B is negative, it's a reflection over the y-axis. C, when we have x minus c, which way do we go? Left or right? Right. And when you have x plus c, which way do you go? Left. And then D is up or down. So the letters are the same. Okay, when we look at the parent function, y equals log base b of x, we're actually going to graph log base 2 of x. And the 3 points that we can get are 1, 0, base 1, and base squared 2. So this would be 1, the first point would be 1, 0. The second point would be, what's the base there? 2. So 2, 1, and 2 squared is 4, 2. So when we plot those points, so 1, 0, 2, 1, and 4, 2. And then it has a vertical asymptote of x equals 0. That is part of the graph. You need to graph that. So we put an asymptote with a dotted line. The function will never ever touch x equals 0. Get really, really close, but it'll never touch it. Okay. Based on that diagram, the x-intercept is 1, 0. The vertical asymptote is x equals 0. What's the domain? What are the possible x values? X is greater than 0, good. And what's the range, the y values? All real numbers, good. So you could write this as 0 to infinity if you want, or you could write this as negative infinity to infinity. It will be x is greater than, it depends upon if it reflects. But if you look at your graph is, I'm going to color it in yellow. Your graph is on this side of that line, x equals 0, and it never touches it. So it's greater than. Okay? So you can think about it that way. So the first question they ask us is, given the function f of x equals log of x, and it's transformed to the 3 functions below in a, b, and c, and they want us to say how were they transformed. So what does the 3 value represent? A vertical stretch. Okay, so it's a vertical stretch by a factor of 3. And then did you go left or right 5? Left 5. Anything else?
No.
Nope, we're done. Okay, letter B. That negative out front, what does reflect? Over what axis? And that x minus 2 moved me right 2. Good. See? Okay. That 1/2 out front, it's a vertical what? Compression by a factor of 1/2. So if your scale factor is 1/2, you're going to get smaller or vertically compress. Do we go left or right 2? Left 2 and up or down 2. And we're done. Easy schmeezy. Nope. Nope. We're not. That doesn't get more complicated than that. Not much. Okay. Let's. Well, we'll get to the back in a minute. Let's try number 2. Okay. The function f of x equals log of x. That's your original function, and it's transformed to be g of x. So you're going to start every single one of your equations with g of x equals. And then we're going to figure out, and it starts out with log. And if you move right 3, what do I put in the parentheses? X minus 3. And if I move up 5, what do I put at the end? Plus 5. And if you vertically stretch by a factor of 4, where does that 4 go? Up front. And there you go. Okay, in letter B, we're reflected across the x-axis. So, negative. There's a negative out front. Translated left 2, so x plus or minus 2. Plus 2. Down 3. So plus or minus 3 at the end. Minus 3. And vertically compressed by a factor of 1/3. So there you go. All right, C. It says horizontally stretched by a factor of 3. So now that's A or B value? B. So does it do anything vertically at all? Do you see vertical in there? So we're just going to write log. Okay, so the B value is the first thing. So if you horizontally stretch by a factor of 3, you're going to flip that 3 upside down or take the reciprocal and put 1/3 in there. Okay, if you translate right 5 as x plus or minus 5 and down 2, minus 2. There you go. So things that happen inside these parentheses are kind of like the opposite. So if you're horizontally stretching by a factor of 3, you're going to take the reciprocal of 3 and use it for your B value. Okay, good so far? All right. So it says, describe the transformations, make a table with at least 3 ordered pairs, graph the function, list the equation for the asymptote, and find the domain and range. And the asymptote is also part of the graph. So if you have a base 2, this little number 2, log base 2, that's your base. So it's 1, 0, base 1, base squared 2. That's where you're starting. Okay, so what does the 2 represent? Vertical stretch of 2. Does that affect your x or y value when you're doing things vertically? Your y value, so you have 2y. And then what does that 4 do? Up 4. So we're just going to have 2y plus 4 there. And nothing happens horizontally, correct? So the x values are just... Okay, so before we lost our connection, the base is 3. So we have 1, 0, base 1, base squared. What's 3 squared? 9, 2. Okay, so those are your points. Left or right? We went left 2 and down 1. Can I pick up the pace a little bit? I'm going too slow? Okay, please do. Okay. So x minus 2 and y minus 1. So this would be negative 1, 0, 1. And this would be, what's 1 minus 2? Negative 1, 1, and 7? Is that right?
Yes.
Okay, so then you plot those 3 points, negative 1, negative 1, 1, 0, and 7, 1. And what's your vertical asymptote is right there, x equals negative 2. So you plot that. Okay, connect the dots. It looks something like that. Your domain is x is greater than negative 2, and your range is all real numbers. All right, so this one, what's the base of this one? 10. So now you have 1, 0, 10, 1, and then you'd have 102. So we're just going to graph 2 points. That 2 out front, that negative 2 is going to affect your y value. So this would be 0 and negative 2. And then does the x value change at all? No. So 1, 10. So this is a reflection over the x-axis and a vertical stretch of 2. So we didn't move right or left, so your vertical asymptote is going to be x equals 0. And we have the point 1, 0, and 10, negative 2. Is that right? 1, 0, 10. Okay, so now you're going like, I think it's like this. Yeah. So you reflect it over the x-axis. X equals 0. Domain is x is greater than 0, and your range is all real numbers.